Hi friends, so today we are going to learn about electric field. Now let's say we have a point source charge Q1 placed in vacuum at the very origin. We also put test charge Q2 with position vector r as you can see here. Thus, according to Coulomb's law, Q1 will exert a force on Q2 and vice versa. But note that we'll consider all the effects on Q1 due to Q2 as negligible. Now I may ask that when Q2 is removed, is there something in the surrounding? Is there nothing? If there's nothing, then how? How Q2 in the first place has a force acted on it? So to explain it all, we introduce the concept of field. According to it, Q1 produces an electric field everywhere in its surrounding. Thus, it's an entity due to Q1 in the space. Now, when Q2 is put at R, the field or entity there acts on it and that field produces a force on Q2. Also, the field signifies how a distributed quantity or entity varies in space with position. Now, electric field at R is equal to 1 upon 4 pi epsilon times Q1 by R square times R cap. Also, F at R is equal to 1 upon 4 pi epsilon times Q1 Q2 by R square times R cap according to Coulomb's law. Thus, F at R is equal to E at R times Q2. Here, R cap is the unit vector along R and epsilon is permittivity of medium. Thus, by dimensional analysis, the unit of electric field is newtons per coulomb or volts per meter. Also, we can see that electric field at R is numerically equal to electric force on Q2 is equal to 1 coulomb at R. The above is just for making sense. Q2 is a very small test charge and electric field is independent of Q2 as seen in its equation. As we can see, electric field does depend on source charge Q1 and position of a point in space from source charge R and falls as reciprocal of R to the power 2. Also, for positive charge, electric field's direction is radially outward and for negative charge, electric field's direction is radially inwards. Now you may ask that we learn according to Coulomb's law that Q1 and Q2 are interacting. How come this field then? Yeah, but the field itself is produced by Q1 and indirectly applies force on Q2 later on by the field itself. It can be looked as interaction between Q2 and Q1's electric field and vice versa. At last, in electrostatics, electric field is convenient and is not a necessity. But as we advance and deal with things like time-dependent electromagnetic phenomena, it becomes important and a key to learn those. Hope you like the video. Please like, subscribe, comment and share this to as many people.